Hello, and welcome to my YouTube channel. I will teach you statistics, mathematics, and daily LeetCode questions. Okay, so today we are going to discuss the question number 124, binary tree maximum path sum. This is a LeetCode hard, and I will teach you how to do this in the most optimal way, intuitively. Okay, so the question says that there is a path in a binary tree sequence, and there are some nodes. So if you can select a path, these nodes have some values. So you have to select a path in such a way that every node only appears once, first of all, and the sum of all values in the path is maximum among all paths, right? Okay. So one approach, brute force, will be what? Check all paths, right? Find sum, select maximum, right? Okay. What can be the other thing? The other thing can be we traverse all the nodes, right? And find max path of each node, right? Okay. So first we'll have to go to every node. So traversing every node will be some kind of recursion, and then find sum of all child nodes left and right, select child that gives maximum path, right? Okay. So let's say we have a tree 1, 2, 3. Okay. Right now I'm at root. Okay. I want to know what is the maximum path, right? So it can be either this or this, right? So 2 plus 1 is 3, and 3 plus 1 is 4, and so the answer would be 4. Okay. Now the path does not have to go through the root, right? And it can contain any node in any way, right? So we can take this path also. This is also a path, right? So in a tree like this, this can be a path. This can be a path. This can be a path, right? And this can be a path, right? Among all these paths, which is the max path you want to calculate? Okay. So now we know there are two kinds of paths, right? Our observation is there are two kinds of paths. One is that is going like this, and the other is that is going like this, right? So every subtree can have two paths. One is from the child, two kind of paths. The first is through only one child, and second through both childs. Right? So if you take both childs, if you take a path something like this, if you take a path like this, right? If there was a node above, you cannot go up, right? So you have to choose. You want to take this, or you want to either choose one of them or and go more up, right? If you choose one of those, then you have to go up. You cannot take this also and then go up, because it will repeat, right? If you go like this, then one will repeat and then you have to go. That cannot be the case. It has to only appear once. Okay. So considering this, we will check for every root, for every node. So for root, we do basic recursion. How we do? First, we go to the left child, right? So what we do in recursion? We go to left, then we go to right, and then we check if it is a leaf node. So first we go to left, then we go to left, then we go to left. This ends here, right? So this, let's say it has value 3, 4, 2, 1, 5, 6. Okay. So first we go to 2, then we go to 4, then we go to 3. We haven't calculated anything yet. Okay. From 3, we will send 3, right? Let's say this is -5. Okay. We send 3. Okay. Now for 4, we will send 7, right? Because 4 does not have a right. There is no right. This is none. Okay. So from right, there is nothing coming up. So till now, till 4, the maximum is, because there is no negative, so the maximum is 7, right? 7. Okay. So we will send the maximum up. We know the max path from 4 and down below is 7. Okay. Now we send 7 to 2. Okay. And we send 11 to 2 from the right. Now, two kinds of sum I told you, right? One would be 7 plus 2 plus 11, right? So this path is 20. The other thing is, we take maximum of one child, add it to the root, and then send up. So this will be 13, right? Now, among all these paths, how will we know which is our best path? Because till now, our best path is this one, 20. And it is in a subtree. It is not going through the root, right? So we need a global variable, let's say sum of path equals to 20. Now, if we get another sum that is greater than 20, we will update this. Okay, this is our global variable. Okay. Now, 13 goes up. You have to note that 20 does not go up, because 20 is in a subtree. We cannot repeat it again. We have to send 11, 2 to 1, right? 13 will go up. Now 13 is going up from here, and then root left is covered. Now root will go to right. It goes to -5. It goes to 6. 6 is sends above, right? This is -5. So -5 does not have a left child, so it sends 1 above, right? 6 minus 5 is 1, so it sends 1 above, and this has 13, this has 1, so the maximum would be 13, right? So the maximum here will be 14, right? Note that we can take this subtree also. So we can take 13 plus 1 plus 1, which is 15, right? So the path, what would the path like? It will be like this, right? 11 plus 2, which is 13, plus 1, which is 14, plus 1, which is 15, right? Minus 5 plus 6. Okay. So we get the answer 20 because it was not updated again. And our path will be 4, 2, and 11, right? No, you also have to see that every time we don't have to check every child node. Only its left child node sum, max sum, and right child node max sum. Okay. So what will be our pseudocode? So first you have to declare your global variable. Let's say max sum till now is something negative, right? Because the values can be negative also. Okay. So I'll say nodes. These are our rules for the problem. Nodes appear once in path. Sum is max of path. Values can be negative, and it has to get at least one path. Path cannot be null. This means at least one node is needed. Okay, these are our rules. Separate this. So the pseudocode would be, first we have to take a global variable which we will store everything. Next, we will define a recursion function. In this, we will say root. Okay. I don't prefer to send sum because it will just take up space in our recursion and we don't actually need it. First basic thing, if not root, basically we have a null node. We return 0 because the sum is 0 for null node. Then we go to we take the sum of left child. So we say recur root dot left. We say, and this plus root dot value. Okay. We say recur root dot right plus root dot value. Okay. Now we know the sum from left child and we know the sum from right child. Okay. Now there can be two possibilities. As I said, one can be for the subtree only. So because we are adding that root value to get the maximum path like this, like the maximum path for this and maximum path for this. So we don't have to. So one answer can be A plus B plus root dot value, right? Which is this subtree path. Okay. This can bear one value. So we take max of this and store it in our max path. So our max path equals to max path. A plus B equals root dot value, comma. Then it can be A right? It can be, so the root can be negative, so it might be decreasing the value. It can be either A also, or it can be B also, or what else? It can be only root value also, right? So maybe the paths coming from left and coming from right can be negative. So it can be all the possibilities, basically. Okay. Now we return. So let's say our answer we stored in this. Okay. But for every root, for every node from that recursion, we have to send what? The maximum, right? So the maximum sum can be between A. So we have to send max of. So from each node, so let's say this is our path. This is our left, send something, right, send something. Now this root will send maximum of either A plus root node or B plus root node or only root node, because these two can also be negative path sums, right? So it can be A plus root value, comma B plus root value, comma only root value, right? Whichever is the best. So we can select either this, or only this, right? So we return this. We call our recursion function. Recur root, and then we return sum. Okay, so we return max sum, and our answer will be voila, correct.
To start the coding part, and I want to tell you how to do basic codes in the tree, and every question will have these kind of basic patterns, and then why is this question a little different, I will tell you. So first we will initialize our max sum as the minimum negative number that we can take. Then we define our max path, start with the root. Okay, so one of the basic things is if not root, so we have reached the null pointer. So after our leaf node, if or any node which has do not have a left or a right, it will reach here, and then we have to return 0, right, because it has no sum. Then we will take max path of root dot left, right, equals to max path of root dot right. So the sum from left, this will be sum from right. Okay, and then first thing we have to do is update our max sum. Okay, so the max sum will be max of, definitely first will be self dot max sum, right, max of that. Then so our max will be from left and root node or the subtree. So the first thing we will take is the subtree. Okay, A plus B, left plus right plus that root dot value, right, because of that subtree max. Second would be A plus root dot val, right? It can be the root node plus the left child or right child plus root value, right? That is one path. Left plus root is one path, right plus root is one path, and only root is one path, right? Because left and right can be negative. Now from this node, now we have found what is the maximum sum path of this particular node from left and right. Now we have to send this to its parent, right? So what will we send? We can send either only this value, so we have to send some maximum, right, because we cannot just send this root's value, or the whole path sum, because it cannot be appear once. It has to appear once. So it can be from left plus root to up, from right to root plus up, right? One path can be from right, one path can be from left, or if both are negative, you only take the root node. So we take only root node, or a plus root dot val, that is left path and right path, right? This we will return to the parent. Okay. We initialize our recursion function and then we return our serve.max sum. Okay. Now we will run it. Okay. Submit it. Right. So one thing I want you to do is take a particular case and dry run on this. Okay. Dry run this, and then it will be easier for you to understand what is happening here exactly. Okay. Thank you.
貴様の拳などかほどにも効かんわい。お前はもう死んでいる。何？そうは匠できれぶ。貴様の拳などかほどにも効かんわい。お前はもう死んでいる。何？そうは匠できれぶ。貴様の拳などかほどにも効かんわい。お前はもう死んでいる。何？そうは